Okay, so today we are going over how to use the point-slope form of linear equations. So if we're going to write linear equations in point-slope form, we are going to need a point on the line, but it can be any point on the line. It doesn't have to be specifically the y-intercept like we were using before, and we need the slope. So the point-slope form of an equation is used with any given point on the line, and we'll use the x1, y1 to denote that, and the slope is still your m, and it's going to look like this. Y minus y1 equals m times x minus x1. So this is our point slope form. Now, if you remember from the previous lessons, we also had slope intercept form. And that form also required a slope, but the point that you needed for this one was the very specific point of the y-intercept. And this one was y equals mx plus b. So we're still going to be using this one a little bit as well today. Okay, so let's go over how to use point-slope form. So if we want to put an equation into point-slope form, as long as we are given any point on the line, it doesn't have to be the y-intercept, it can be any point, and we're given a slope, we can write it into point-slope form. So the point that we're given is going to represent the x1 and the y1 of the point-slope form. So notice here, it's y minus y1. Well, the y is going to remain a variable, and we're going to substitute the number in for the y1. Same thing over here, we have m times x minus x1. The number of the point here is going to go in for the x1, and the x and the y are going to remain variables. So if I'm putting in this y1 here, it's going to be y minus 1. And then, of course, the slope was -3, so that -3 is going to replace the m. And then x minus 5 is going to be x minus x1. So let's do a couple examples. So the first thing that I'm going to do is I'm going to write out my point-slope form, which is y minus y1 equals m times x minus x1. So now, looking at the information that's provided to me, I know that this point is x1 and y1, and of course my slope is the m. So the x1 is my -3, so that's going to go in over here. Then my y1 is this -2, so that's going to be substituted in place of this y1 here. And then my slope is 5, so that 5 is going to go in where that m is. So let's see what that looks like. So when I go to plug this in, I'm going to have y minus a -2. Notice I'm putting a -2 in place of that y1. Then I have equals my slope, which was 5. So that 5 is replacing my m. And then I have x minus -3. So my -3 is replacing my x1. Now this would be complete, except that we want to simplify our answer so that we do not have any double signs in our final equation. So if you do end up with any minus negatives, you want to rewrite that simplified as a positive. So instead of y minus -2, we're going to write that as y plus 2. And then on this side, we would have 5 times x plus 3. And then this would be our final answer in that point-slope form. Okay, so let's take a look at the next one. So again, we have our x1 and our y1, and then of course our slope here. So I like to sometimes write out the equation first so I know exactly where I'm substituting everything in. So like I said in the last equation, so the x1 is going to be this 1 here, so that's going to go in over here for x1. My y1 is this 4, so that's going to go in and be subtracted here. And then my slope is this -4, and that's going to go in for my m. So I'm now going to have y minus 4, since that's my y1, equals negative 4 times x minus 1. And there's no double signs here that need to be simplified, so this would be my final answer. Okay, moving on to number 3, same process, x1 and y1. Those are the points I have there. So if I write down my equation, y minus y1 equals m times x minus x1, and then I look to see what am I going to substitute where. So my x1 is going to be the 6, and that's going to be subtracted down here at the end. My negative 8 is my y1, so that's what's going to be subtracted here. And my slope is the fraction 4/9, and that's going to go in for my m right there. So now when I do my y1, I'm going to have y minus negative 8. My slope is a fraction of 4/9, which doesn't change anything. You're just going to put it in front of the parentheses as we would normally. And then x minus my x1, which happens to be 6. Now in this case, the 6 did not give us a double sign because we were subtracting just a 6. But in the front, we were subtracting a negative, so I'm going to simplify that by making it y plus 8. And then this is now my final answer in point slope form. Okay, so now we're going to do some graphing in point slope form. So here's my equation, y minus 2 equals negative 4/7 times x plus 4. So in order to graph this, we need to find the slope and the point that's being given to us in this equation. So if you look at this equation, right, and I'm going to write just the generic formula first. So there's my point slope equation, and then right underneath it I'm going to write the example that we're being given, just so that everything's kind of organized and we can really see what's going on here. Okay, so now in this equation, if I look at the y1, I can see that that's going to be 2. Now, this is where some people get a little bit confused because sometimes the signs can be a little tricky here. So when I'm looking for my y1, the y1 is what's being subtracted from my y. And in this example, we can see that we're subtracting a 2. So the y1 is just going to be positive 2 because it's what's being subtracted. Then the slope is pretty easy to identify because it's just going to be that value that's in front of the parentheses, and whatever the sign is, it is. So the slope here is just negative 4/7. The tricky part in this example, though, is this x1. Because notice that my signs are not the same here. So in the formula, I have x minus x1, but in my example, I have x plus 4. So we have to kind of ask ourselves, well, what was being subtracted here? If that's a plus 4, I was really subtracting a negative 4 in order to get that plus. And so really, my x1 is then a negative 4. So the way you really need to just think about it is that whatever sign you see in the example in front of that number, when you pull it out as a point, you're going to have the opposite sign on your answer. So if this is y minus 2 and I see a negative or a minus sign in front of my 2, I know my answer is just going to be 2 when I write the point. And over here, if I see an x plus 4, like we did in the original problem up here, then I know when I pull that 4 out, it's going to be a negative 4 when I'm identifying my point. And that's what we have to remember, and that can be a little tricky at times. Now, once you get the point and the slope, you're going to plot your point and then use your slope as a rise over run, just like we do with slope-intercept, except that instead of starting at the y-intercept necessarily, it could be any point on the line. So in this case, we're going to start at the point -4, 2. So from the origin, I would go -4 on the x-axis and up 2, and that's where I would make that point right there. And then I would use my slope as a rise over a run. So since it's negative, I'm going to go down 4 and then 7 to the right and make my next point. And that's where this line is coming from that you can see here on this example. So let's try that. All right, so again, I'm going to write down the formula itself just as a reference here. And then I'm going to write down the question that was given to me underneath. And then because these signs are not matching up, I'm going to rewrite it as minus -3 because I know that's where that plus came from there. And then here I'm going to write minus -2 because I know that that's where that came from there. And now I will be more easily able to identify what is that x1. It's the number being subtracted. What is my y1? It's the number being subtracted from y. And then, of course, what is my slope? And that pretty much stays constant throughout. So what is my point? What is that x1, y1? Well, my x1 is this -2, and my y1 is this -3. Now notice the signs on the 2 and 3 are both negative. In the original problem, we had pluses, so we know that they're going to be the opposite, and that's because we're really subtracting a negative there. And then, of course, my slope is that +4, which I can write as a fraction by putting it over 1. So now to graph this, once I have identified my point that's in the point slope form, which is -2, -3, I can plot that on my coordinate plane. I'm now using my slope as a rise over run. So I'm rising 4, so going up 4 and then running 1 to the right. Rising up 4, 1 to the right, rising up 4, running 1 to the right. And that's how I would get my line. Okay, so using point slope form to write an equation. So now this time I'm going to write the equation, but I'm going to get the information off this graph. So again, if I'm going to put something in point slope form, I need a point and I need a slope, right? So you need a point. It could be any point in the line, and you need a slope. Now in this case, they're already giving us two defined points right there that are nicely labeled. So it makes sense that we use one of those. Obviously, there's many other points on this line. You could really use any of them. The rest of them would all be some sort of decimal or fraction value. So we probably wouldn't want to choose that. It would just make things a little bit more difficult. But if they're already identifying points for you that are nice integers, I would just stick with one of those. Now we do need the slope, so we have a point. We do need a slope, however, so since I have a picture of the graph in front of me, the easiest option is to use rise over run. So if I'm rising 1, 2, 3, 4, 5, and then I'm going to go to the right 2. So my slope using rise over run would be 5 over 2. Now, if you'd rather use the slope formula, that can also be done as well. So I could do -2 minus 3 and 1 minus 3, which would be -5 over -2, which of course simplifies to 5 over 2. So whether you use rise over run or the slope formula, you should get the same answer either way. If you have a picture of the graph, you at least have the option. If you don't have the picture of the graph, then you have to use slope formula. So at this point, there's only one slope, regardless of how you get it. However, when you go into point slope form, there's no restriction on which point you use. And we had 2 points given to us. So we can do this using the first point, 3, 3, or we can use the second point, 1, -2. So I'm going to show you how you could get it either way. So there'll be 2 different answers, but they would both be correct point slope form answers. So if I were to do 0.33, the 3 is going to be my x1 and the other 3 is going to be my y1. So I would have y minus 3 equals my slope of 5 over 2 times x minus 3. So this would be one of my answers in point slope form. Now if I use the other point, this one over here, as my x1 and my y1, then I would have y minus negative 2 equals my slope of 5 over 2 times x minus 1. And then, of course, I would have to simplify that double sign there, making it y plus 2 times 5, and then equals 5 over 2 times x minus 1. So notice I have two different answers in point slope form. They both have the same slope because the slope of the line will never change. It's the same constant slope throughout all of the points. But in this example, my x1 and my y1 were different than the other example. And that's because it's not restricted to a specific point on the line. Any point on the line is fine. And the reason that this is something that we can do is because if we went to check this and we wanted to check to see if they're the same by putting them in slope-intercept form, which is your y equals mx plus b, you would see that they will both end up being the same. So I'm going to do that here so you can see. So if I want to put this into slope-intercept form, I would first have to distribute the slope to whatever is in those parentheses there. So I still have y minus 3, and then I would have 5 over 2x, and then when I multiply my 5 over 2 by the 3 over 1, I end up with 15 over 2. Then I would add the 3 to both sides. Now I have y by itself equals 5 over 2x, and then negative 15 over 2 plus 3. You could do it on a calculator, or you could just kind of do it by adding your two fractions here. Remember, 3 is really over 1, so I'm going to make that a 6 over 2, and then that becomes negative 9 over 2. And you're certainly welcome to use a calculator to check that as well. Now when we go to look at the other one here that we had, even though they were different, they were both point slope form of the same line. So when I distribute my 5 over 2 here, I get 5 over 2x minus 5 over 2. Then I subtract 2 to get my y by itself. Y equals 5 over 2x. And then I have to do negative 5 over 2 minus 2, either over here on the side or on my calculator. And again, I'm going to get negative 9 over 2. So you can see that your slope-intercept form has to be the same because the line only has one y-intercept, and that's the specific point that we're looking at in that form. Whereas in point slope form, it's using any point on the line, so you can have different answers for an equation for point slope form, and they can both be correct. So the last thing we want to do is use this form when we have 2 points. So if you remember from the previous lesson, when we have 2 points given to us, we would have to first find the slope. Now we did the same thing in the last examples, it's just that we had the graph in front of us, so we could just use rise over run to find the slope. But in this case, we don't have the graph, so we're going to use the slope formula. So I'm going to do my y2 minus my y1 over my x2 minus my x1. Now this will give me negative 21 over 7, which will simplify to negative 3. So now I'm going to put this into my point slope form. And you actually have two options here, right? So we can do point negative 3, 8, or we can do point 4, negative 13. Either option is okay. So if I use this point here for my x1, y1, I will have y minus 8 equals my slope, which was negative 3, and then x minus negative 3, which is going to simplify to that plus 3 there. If I use the other point as my x1 and my y1, I will have y plus 13 equals my slope of negative 3 times x minus 4. So notice there are two correct answers for point slope form. However, if I converted these to slope-intercept form, they would both give me the same answer. All right, so we're going to try that for this example as well. So first we're going to find our slope. So I'm going to use my slope formula here. So 8 minus negative 6 and negative 6 minus 10. This is going to give me a positive 14 over negative 16, which is going to simplify to negative 7/8 as my slope. So now for number 2, I'm going to put this into my point slope form. But as we know, we have 2 options for that, right? So we could use the first point, which is 10, negative 6, or we could use the other point, which is negative 6/8, and either one would be correct. So if I do my first one, I'm going to have y plus 6, because I'm going to subtract that negative 6, which will simplify to a positive, equals my slope of negative 7/8, and then x minus 10. If I do this point here instead, I have y minus 8 equals my slope of negative 7/8, and then x minus negative 6, which will become a plus. And these would both be correct answers for the equation in point slope form. However, if I simplified these or converted them into slope-intercept by distributing the slope and then bringing that 6 or 8 to the other side, you would get the same answer if you did it correctly. So let's just review some of that now. Okay, so these are the 3 equations that we are going to be kind of using. So the first equation is your slope formula here. Then this one here is our point slope. And then the third one here is our slope intercept. Okay, so what we're going to practice really quickly is getting an equation from point slope form into slope intercept form. Or we could say if we want the equation in slope intercept form, there's 2 ways to do it, right? So one way would be to find your slope, then find your y-intercept the way we did yesterday, and then writing the equation in slope intercept form. But today we're going to get the same end result. We're going to write the equation in slope-intercept form, but we're going to do it by a different method. We're going to do it by the route of using the point slope form instead of finding the y-intercept. So the first thing we would want to do is find the slope, and that's already done for us in this example, so we don't really have to worry about doing that step. So the second thing we would do is put it into point slope form, and they're giving us one specific point to use. So we are going to do y minus 2 equals the slope, which is negative 1/2, and then x minus 6. So that is my answer in point slope form. Now I want to put it into slope intercept form, which is essentially just getting that y by itself. So what I would have to do now is distribute that 1/2. So negative 1/2 x, and then negative times negative will be a positive, and 1/2 times 6 works out to 3. So I have y minus 2 equals negative 1/2 x plus 3. The last thing I would have to do to get the y by itself is bring that 2 over to the other side. So y equals negative 1/2 x plus 5. So this would be my answer in slope intercept form. All right, so let's try for number 2. So step 1 is nicely done for us. We just have the slope of 4. So we're going to use the one point that's provided, and we're going to put it into point slope form. Now this one is 1 with the negative, so y minus negative 1 equals 4 times x minus negative 3. So remember, whenever that happens, you just have to simplify those double signs. And you would have something that looked like this. So now we want to get it into slope intercept form, which means we need to get rid of our parentheses over here. So I'm going to distribute the 4, making it 4x plus 12. And then finally, we get our y totally alone by moving that 1 to the other side. and I would have 4x plus 11. All right, so now on the next two examples, this time we're going to have to do a little bit of work for that first step of finding the slope. Okay, so if I have x1, y1, x2, y2, I'm going to do negative 3 minus 3, and then 2 minus 0. That gives me negative 6 over 2, which simplifies to negative 3. Now this time I have two options for my second one, right? So I can either do the first point, which would be y minus 3 equals my slope of negative 3, x minus 0, or I could do the second point, which would be y plus 3, because we're going to minus that negative, equals my slope of negative 3, and then x minus 2. Now, either one of those is fine, but now we're going to get it into slope-intercept. Now, I want to show you how we're going to get the same answer in slope-intercept regardless. So if I were to do this first one here, well, first of all, x minus 0 is really just an x, so I don't need to really write out any more there. And then all I would have to do is add my 3 to the other side. Just make sure you don't combine the negative 3x and the 3 because they are unlike terms. So that would be my answer in slope-intercept form for that. Now, if I had done the other equation instead, I'm going to distribute my negative 3. So I have y plus 3 equals negative 3x plus 6. Subtracting the 3 from each side, and it would leave me with y equals negative 3x plus 3. So notice, even though I had two different point slope form equations, I end up with the same slope intercept either way. Okay, number 4, finding the slope. So I'm going to do 2 minus negative 1 and 4 minus 1. Remember, when you minus the negative, you're really adding. And this time my slope is 1. So now to do my point slope form, with the first point, I have y minus negative 1, which I'm going to change to a plus, equals 1 times x minus 1. If I use the second point instead, I would have y minus 2 equals 1 times x minus 4. Now, either of those should be able to get us to the same answer for slope-intercept. So let's see what happens. So in the first example, I'm going to distribute the 1, which of course isn't going to change much. I'm just going to be left with that x minus 1. And then I'm going to subtract 1. And I end up with y equals 1x minus 2. On the second equation, again, my slope is 1. So when I distribute a 1 there, it doesn't change anything in those parentheses. And then I add the 2 to the negative 4. And I end up with y equals x minus 2. So again, same answer in slope-intercept, even though I had two different answers in point-slope form. Okay, so to finish our review with point-slope form, now we're going to go in reverse and we're going to look at our equation and we're going to find the point and the slope that's identified in the equation so that we can then graph it. So like I said to you before, the slope is always the easiest thing to identify because it's just whatever is in front of those parentheses. So when you have your equation in point-slope form, the m is what's in front of the parentheses, and that is just your slope. And you don't have to worry about any sign changes or anything like that. Now the x1, remember, is what's being subtracted from your x, and the y1 is what's being subtracted from your y. So if you see an addition sign in your problem, that means that you were subtracting a negative, so you have to take into account there's a sign change happening there. So my slope is negative 1/4. And then, of course, what is being subtracted from my x here? this negative 3 or minus 3, which means a positive 3 is being subtracted. And then over here I have y minus 1, so that means a positive 1 is being subtracted. So when I go to graph this, I'm going to plot the 3, 1 on my graph. And then I'm going to go down 1 over 4. 1, 2, 3, 4. Or you could go up 1 and 4 to the left. And then that's how you would graph that line. Okay, so let's try that again for the next one. Okay, so again, the slope is going to be a little bit easy to identify because it's just going to be the number in front of the parentheses. In this case, it's just a 5. If you want to put it over 1 to help you with the graphing, you can. Now, as far as the x1 and the y1 are concerned, what is being subtracted from my x? Well, I have an x plus 2 here, so I'm going to have to think opposite sign. I'm really subtracting a negative 2, so my x1 is a negative 2. Now, on the other side, y minus y1. Well, I don't see anything being subtracted there, so that means my y1 must be a 0. So now I'm going to plot the point negative 2, 0. So on my x-axis, I'm going over to negative 2. And then my slope was 5 over 1. So I'm going to rise 1, 2, 3, 4, 5 over 1. If I had more space, I would continue that. And then I could get my line like so. Whoops, sorry, a little crooked, but you get the idea. All right, so let's try another one. Okay, so here it says use point slope form to write the equation. So this time the line is given to us. So let's find the slope and identify a point. Now, if I'm doing rise over run here, I'm going to start from my left point and go to my right point. So I'm going to go down 1, 2, 3, 4, 5, 6, and then over 1, 2, 3, 4, 5, 6. Now, rise over run was 6 over 6. I wrote negative 6 over 6 because looking at this line, since it's kind of going downward, I know it's going to have a negative slope. So negative 6 over 6 is going to simplify to negative 1. Now, as far as which point you're going to use, that's really up to you. So I'm going to choose 3, negative 1, but it doesn't matter which one you pick. So you could do this again with the other point, and that would be correct as well. So now putting it in point slope form, I'm going to do y minus, so here's our formula, y minus y1 equals m times x minus x1. So y minus the negative 1 is going to become a plus sign. Then my slope, which is negative 1, times x minus my x1, which is that 3. So now to put this into slope-intercept form, I would have to distribute that negative, giving me negative x plus 3, subtract the 1. I'm going to get y equals negative x plus 2. So let's try it for one more. So again, I want to find my slope. Since I have the graph in front of me, I can just do rise over run. If you prefer, you could certainly do slope form, but I'm going to go rise over run. So 1, 2, 3, 4, 5, 6 is my rise, and my run is 3. Now I know that this is going to be a positive slope because my line is going up. So 6 over 3 is going to simplify to 2, and we know that that's a positive 2. Now you're going to pick any point you want from the line. So you could pick one of the ones that's marked. You could even pick a different point on the line that's not marked, whatever you'd like. Just to stay consistent, I'm going to pick one of the ones that's marked. And this one here is negative 1, 4. So I'm just going to pick that. If you'd rather do a different one, that's fine. So now I'm going to put that into my point slope form. So y minus 4, since that's my y1, equals my slope of 2 times x minus negative 1, which is going to become a plus 1. Now I want to simplify this to get it into slope-intercept form. So 2x plus 2. Add the 4 to the other side, and we have y equals 2x plus 6. And there you go.